Hello, Fire Tech 101 students. This is the voice narration of the PowerPoint presentation for Chapter 9, Fire and Emergency Services Apparatus, Equipment, and Facilities in our Fire and Emergency Services Orientation and Terminology 7th edition IFSTA textbook. So Chapter 9, the pages that it corresponds with in your text are pages 311 through 343. And the slide presentation is going to run about 106 slides. So we'll go ahead and get started. This will all be done in one module, so we won't break up the lecture. Taking a look at the learning objectives, we're going to look at common fire department apparatus, focusing mainly on the engine and truck company. We're going to identify common fire and emergency services uniforms and personal protective clothing, or PPE, personal protective equipment. Identify common fire and emergency services breathing apparatus. So the two you're going to become most familiar with are the Scott Pack, and most recently several departments have been going to the MSA breathing apparatus. And then we'll identify some common fire and emergency services tools and equipment. From there, we'll move into fire and emergency services ropes, webbing, related hardware, and harnesses. This will be used more in that technical rescue, but there are plenty of times where you're going to use ropes and knots for lowering tools, raising tools, hoisting tools, taking tools above ground, tying off ladders, and then low angle rescue, which is a truck company function, even some high angle rescue, until you get into the more complex USR components. We're going to look at ground ladders. Ground ladders are how we access buildings. Most commonly, we use ground ladders to get on the roof for vertical ventilation. And then there's other forms of access, window access, and also can be used for rescue. We're going to look at our fire hose, our nozzles, and our hose appliances. An appliance is basically anything that water is going to flow through, and then some of the other tools. And we'll finish off by looking at some of our common fire department facilities. Okay, looking at our first section, which is our first learning objective, we're going to identify common fire department apparatus. And again, we're going to focus on your engine and truck company. That is going to be the most common that you're going to see: engine company, truck company, and ambulance. And an ambulance can be referred to as several different things. RA is a term, rescue ambulance. Rescue is what we refer to them in our department. ET, emergency transport, that's another one. And then, ambulance as well. So depending on the agency, you might have a different name for an ambulance. But essentially, a lot of times they will go along with the function. For example, we call our rescues, which is our ambulance that has two paramedics, and those are for ALS transport. And then we have BLS transport, which is EMT level transport. We call those our BLS ambulance, right? So again, they're both an ambulance. They just have some different terminology. So what are our apparatus for? They're designed to perform specific functions at emergency incidents. They may perform only one major function, or could be multifunctional. Some new technologies. Manufacturers continually update and improve fire apparatus. The improvements include additional safety measures and functionality for vehicle and onboard equipment. So how can we keep our personnel safe? We used to have our breathing apparatus and all of our equipment in the cab. We still do. Some have these clean cabs, which all of the equipment, your PPE and your SCBA, are stored outside of the cab for as a safety feature. Seat belts, those have come a long way as a safety measure, and just some of the design for when we sit. How the impact on your body as you're sitting driving, over and over in that vehicle. There's been some big improvement there. Try to increase fuel efficiency and operational readiness, and then available technology depends on manufacturers and the AHJ authority having jurisdiction's determination of what's needed. A lot of that AHJ determination of what's needed comes at the cost. What is the cost of replacing these apparatus. You get into the millions of dollars to replace these apparatus and outfit them with the equipment that they need. So they're very expensive for a city to replace. They're very expensive for the cities to maintain. Some of the advancements, the APUs, auxiliary power units, so they provide the heating, air conditioning, and electrical power while the apparatus is off or the engine is off. Alternative fuel vehicles, you're seeing several of those, mostly EV come into play. These can reduce emissions, oil consumption, and operating costs. Some apparatus rollover protection, large airbags within the passenger compartments that protect personnel in a rollover, and then connected vehicle technology. So you have some sensors attached to the apparatus, subsystems that connect to monitoring control units. Apparatus communication hubs, Wi-Fi spots that enable personnel to track vehicles. We do have Wi-Fi in all of our vehicles. It is basically a cradle to the city's to the city's internet. So that's how our vehicles and our computer-operated data terminals, or MDTs, or they're basically a computer that sits in there. Your dispatch information will come up. They can send messages. You have maps on there. There's a lot of things that those have. But it's essentially a laptop computer terminal that's in the apparatus. Wireless communications allow personnel to remain in constant contact. Vehicle collision avoidance technology detects vehicles near collision. And then traffic preemption systems allows responding apparatus to change the traffic signals along its route. Those are also referred to as an opticom. Opticom is a flashing strobe that's usually somewhere in the center of the emergency response lights, and that if there's a sensor on the pole where the stoplight is, it will trigger that to give you a green. It doesn't just go to green. There's a little bit of delay in changes, but all apparatus need to come to a complete stop before they go through a red light. So those of you that will take tests for driving apparatus, or even if you're going to take an ambulance drive test, you'll want to know that. And then drones or unmanned aerial vehicles. Drones are really big now in the fire service. A lot of good reconnaissance from the drones, a lot of good information gathering. When we use the drone specifically in large-scale incidents, now you have a couple of very significant incidents that have happened in the recent past here in Orange County and LA County, where we can fly the drone and we can get good intel. Our pumping apparatus, or engine, also referred to as a pumper. So these are the most common, and what is their job? You get water in from the hydrant and water out through your attack hose lines. So the main function is to find the fire and suppress the fire, right? So fire extinguishment through the use of water, and then we also have foam tanks on these engines. These should meet NFPA 1901 in the US and the ULC standard in Canada. Your pump, so the tank is on there. Your pump capacity is measured in GPM, the pump capacity. So you can pump anywhere from 750 to 200,000 GPMs. Again, that also, you have the water flow coming in, etc. This is called the pump panel. This picture that you see, it's commonly referred to as the pump panel, and this is just a series of gauges and controls where essentially what you're doing is you're pulling levers to get water out of the attack line, or also you'll have levers that you pull and they're just opening gates, right? So they're opening valves so that you can have an intake and you can have a discharge, right? That's essentially what you have on your apparatus. What you see up here in these cross lays, those are going to be what's called pre-connected. Generally, there's the piping system. There's a hole in the bed here, and what you'll do is you'll connect to a pre-plumbed system. All right, so those are called pre-connects. This rubber line here, we have these. Not everybody does. Those are called booster lines. We refer to them as a booster line. They're just small hose that can be used on some small fires. You have a series of gauges here that will tell you what the pressure is, pressure coming in, pressure going out, and then also you can use this to go. They have volume and pressure, right? So volume, larger fires, we need a larger volume of water. So you have both pressure and volume controls there. Our apparatus or pumpers or your engines are going to have a tank. That tank could be anywhere from 500 to 1500 gallons. So it doesn't take a ton of water to initiate a fire attack, particularly in a house fire where you're not opening the bale and just free flowing water, where you're strategically opening and closing the bale to flow water. So depending on how many GPMs, if you're putting out 150 GPMs a minute, and that's 300 every 2 minutes. So if you have a 500-gallon tank, you have less than 4 minutes, right, before you have to have a water supply established, meaning water has to come in. Okay, so that's how that works, right? So you don't want to, if you draw too much water out of your tank, you'll end up cavitating the pump, right? So you got to make sure you have a water supply established at some point before you use up all the water in your tank. But you can charge, meaning charging a hose line, meaning that's putting water into a hose line. So the firefighter will pull that hose line, get to the door where they want to go into the fire. They can call for water. They can charge it before the water supply is established. But again, you have only a very limited amount of time before you're going to utilize all the water in that tank. So you need water coming in. All right. Says a special feature on there is additional tanks for extinguishing agent. Up here in this area here, if you look on our apparatus, you'll see that there is a couple of tanks that we use specifically for different types of foam. Our hose beds, so we usually have a hose bed, the one that I showed you in the video, which is a cross lay. We'll go back. Oops, sorry. Okay, so you usually a hose bed here that runs the length of basically the bed of the truck. It goes up to the pump panel and then to the end, and then your cross lays here, which are perpendicular to the bed there. Those are our hose beds. There's going to be several different sizes of hose and different configurations. So we use a 3-inch supply line. There's 4-inch supply lines and 5-inch. And those are the hoses that hook up to the hydrant, and you get water from the hydrant into the engine, all right, into the tank. So they hook up to the hydrant, they hook up to an intake, and then water flows from the hydrant in by releasing a valve that allows the water to flow into the tank. We have attack lines. Those are the lines that we're going to pull to the location where we want it, and then from there we're going to attack the fire. So water goes from the tank through the discharges and into those hoses, right? So 1 3/4 and 2.5 are very common. That booster line is a 1-inch typically, or there's also some 1-inch hose lines that you can use for wildland. All right, so several different sizes and then different arrangements of hose. Typically in those cross lays, you're going to have 1 3/4. We have 2.5 and 1 3/4 off the back with 3-inch supply lines, right? So the supply lines may differ depending on the agency. So I've seen 3-inch, 4-inch, 5-inch, kind of just depends. It says fire attack lines may be pre-connected. I covered that in one of the earlier slides. So basically a pre-connect means that the hose lines are already attached to a discharge outlet. So once you pull the hose off, there's no connection you need to make to get water in it. You just need to pull and release the valve, right? Okay. Those lines are going to have a nozzle attached to it. There's several different kinds of nozzles. We'll cover that a little bit later in this chapter. NFPA 1901, that's going to provide the information on the minimum hose size and length requirements that you need for an engine. Some of the equipment we carry, not a ton of ground ladders. We carry 2 ground ladders and an attic ladder. So our ground ladders are going to be either a 20 or 24 foot extension, meaning you have a halyard, which is a rope that you use to pull. So there's 2 sections of the ladder that lay on top of each other. And then one section is called the fly that will extend up. Ours are 20 and 24 feet. And then we usually have a ground ladder that is a straight ladder